Next example, expand sin x in ascending power of x minus pi by 2. So next example is of the same type. Next two examples. So these are the examples on Taylor's theorem. That is, these are not examples on Maclaurin's theorem. So if the question is expand sin x in ascending power of x, or just expand sin x by using Maclaurin's theorem or Taylor's theorem, then use Maclaurin's theorem, the expansion of sin x. In order to obtain the expansion of sin x, use the Maclaurin's theorem. But here the expansion of sin x in the ascending power of x minus pi by 2. It is not in the ascending power of x. It is in the ascending power of x minus pi by 2. So in order to solve such a type of examples, use Taylor's theorem. So what is the Taylor's theorem? F of a plus h is equal to f of a plus h f dash a plus h square by 2 factorial f double dash a plus h cube by 3 factorial f triple dash a, and so on. So this is the Taylor's theorem. So take h as x minus pi by 2. If it is x plus pi by 2, then take h as x plus pi by 2. So x, it is h, actually h is what? X minus a. So here a plus h as x, we take a plus h as x, means h is x minus a plus h as x. So h is x minus a plus h as x, means h is x minus a. And so it compare, if you compare this x minus pi by 2 with x minus a, then we have a as pi by 2. So if it is x plus h by 2 in the ascending power, x plus h by 2, then if we compare x plus h by 2 with x minus a, then a becomes minus pi by 2. So h is x minus a. And then take h of x minus pi by 2 as x minus a. So a is pi by 2. F of a plus h means f of x. Take a plus h as x. And take fx as sin x. And then find f of a, f dash a, f double dash a. In order to find this, we use find f dash x. No, right? This is the next step. After fx is equal to sin x, write this step. That fx is sin x, so f of pi by 2. F of pi by 2. Okay, here is f of pi by 2. F of a. The first term is what? F of a means you have to find the f of pi by 2. So f of pi by 2 is sin pi by 2 is 1. Then f dash x. Then we have to find f dash a. A is pi by 2. So we have to find f dash pi by 2. Because here f of a plus h means fx is sin x. F of a means f of pi by 2. H means x minus pi by 2. H is x minus pi by 2. F dash a means f dash pi by 2. Then h square means x minus pi by 2 bracket square by 2 factorial. F double dash a, f double dash pi by 2. A is pi by 2. Similarly, substitute h as x minus pi by 2 bracket cube by 3 factorial, f triple dash pi by 2, and so on. So we have to find the value of f of a, f dash a, f double dash a, means we have to find the value of f of pi by 2. So this is f of pi by 2, f dash pi by 2. So in order to find f dash pi by 2, first find f dash x. The root of sin x is cos x. And then f dash pi by 2 means cos pi by 2 is 0. Then f double dash x means cos x. The root of cos x is minus sin x. F double dash pi by 2 means minus sin pi by 2 is minus 1. The triple dash x is minus cos x. The root of this minus sin x is minus cos x. If triple dash pi by 2 is minus cos pi by 2 means 0, because cos pi by 2 is 0. F raised to 4x, the root of cos x is minus sin x, so minus 1 becomes plus sin x. F raised to 4 pi by 2 sin pi by 2 is 1, and so on. And substitute these values. So sin x, f of a plus h or fx means sin x. F of a, f of pi by 2 is 1. Then 1 by 2 factorial is 1 by 2 factorial. H f dash a is 0. Then h f dash a x minus pi by 2. The next term is x minus pi by 2 bracket square by 2 factorial f double dash pi by 2. F double dash pi by 2 is value is minus 1. Then the value next term in the value is 0. F triple dash pi by 2. Then f raised to 4 pi by 2 is 1. The next value is 0. Next value is minus 1. If you observe these values, 1, 0, minus 1, 0, 1, 0, all these. Okay. So substitute the values. We have this. Okay. 1 minus 1 by 2 factorial x minus pi by 2 bracket square, this term. Okay, and so on. So this is the expansion of sin x in the ascending power of x minus pi by 2, in the ascending power of x minus pi by 2. This is the first term is x minus pi by 2 raised to 0. This is x minus pi by 2 raised to 4. Next term is x minus pi by 2 raised to 4. Next term is x minus pi by 2 raised to 6. So this is the expansion of sin x in the ascending power of x minus pi by 2. Next example is expand log sin x in the ascending power of x minus 3. So, right, Taylor's theorem at f of a plus h is f of a plus h f dash a plus h square by 2 factorial f double dash a plus h cube by 3 factorial f triple dash a and so on. H is now x minus 3. So if you compare h is equal to x minus a, then a becomes 3. F of a means f of x is log sin x. And then this equation reduces to log sin x. F of x means log sin x. F of a means f of 3. H is x minus 3. F dash a is f dash 3. Then h square x minus 3 bracket square by 2 factorial f triple dash f double dash 3. X minus 3 bracket that's to 3 divided by 3 factorial f triple dash 3 and so on. So now we have to find the value of f of 3, f dash 3, f double dash 3, f triple dash 3. So fx is log sin x. So f3 is what? Log sin 3. Then f dash 3. In order to find f dash 3, find f dash x. Log sin x. Derivative is what? 1 by sin x. The into derivative of sin x is cos x. So cos x by sin x means cot x. And f dash 3 is cot 3. Then f double dash x. The derivative of cot x is what? Minus cosec square x. So f double dash 3 is what? Minus cosec square 3. Then the derivative of minus cosec square 3 is what? Minus 2 cosec 3. Now cosec x into derivative of cosec x is what? Minus cosec x into cot x. And so it will become plus 2 times cosec square x into cot x. And the value at 3 is what? F triple dash 3 is 2 cosec square 3, cot 3 and so on. And substitute these values of f3, f double dash 3, f dash 3, f double dash 3, f triple dash 3 in this. We have this log sin x is what? Log sin 3 plus x minus 3 log cot 3 minus x minus 2 bracket square by 2 cosec square 3, x minus 3 by 3 factorial is 3 into cosec square 3, 2, and this divided by 6 becomes divided by 3, cosec square 3, cot 3 and so on after simplification. So this is the expansion of log sin x in the ascending power of x minus 2, x minus 3 in the ascending power of x minus 3. Okay, so the next example is expand tan x in the ascending power of x minus pi by 4. So tan x is now f of x is tan x, and write first Taylor's theorem that f of a plus h is f of a plus h f dash a plus h square by 2 factorial f double dash a plus h cube by 3 factorial f triple dash a and so on. Now h is now x minus pi by 4. H is what? X minus pi by 4. Because we had to expand this tan x in the ascending power of x minus pi by 4. So compare this h as x minus pi by 4 with x minus a. So a is pi by 4. And f of a plus h means fx. Fx means a plus h means x. And so it is equal to tan x. Fx is tan x. And then result 1 becomes f of a plus h means fx is tan x. Then write a as pi by 4 here and h as this x minus pi by 4. We have this, that f of pi by 4 plus x minus pi by 4 f dash pi by 4. Then h square means x minus pi by 4 bracket square by 2 factorial f double dash pi by 4. Then h as x minus pi by 4 cube by 3 factorial f triple dash pi by 4 and so on. So we have fx is tan x. So f of pi by 4 is tan pi by 4 is 1. Then we have to find f dash pi by 4. So find first f dash x. F dash x is what? F dash x is tan x. Derivative tan x is sec square x. And then f dash pi by 4 is sec square root sec square pi by 4. that is sec pi by 4 and its bracket square. Sec pi by 4 is root 2, its square is 2, right here 2. Root 2 square is 2. Then f double dash x, f double dash x is what? F double dash x is 2 sec x, derivative of this is 2 sec x into tan, derivative of sec x is sec x into tan x, 2 sec square x tan x. And then f double dash pi by 4, that is substitute x as pi by 4. So 2 sec square pi by 4 tan pi by 4, tan pi by 4 is 1, and sec square pi by 4 is root 2 bracket square. So it's become 2 into 2, that is 4. Here write 2, and write 2. And then f triple dash x. So it's derivative u into root 2 as it is. Derivative of sec square x is what? 2 sec x into tan x as it is. And plus sec square as it is, derivative of tan x is sec square x. So simplification is 2 sec square x, 2 tan square x plus sec square x. Okay, by taking sec square x as common. And then value at pi by 4 is 2 sec square pi by 4 is 2, in bracket 2 tan square pi by 4 is 1 square is 1, and sec square pi by 4 is 2. So 2 plus 2. So we have 16 and so on. Substitute these values in equation, this equation number 1. So we have f of x means tan x, f of pi by 4 is 1 plus 2 x minus 5. The value of this quantity is 2, f dash pi by 4. Here f dash pi by 4. Here write 2 into x minus pi by 4. And then x minus pi by 4 bracket square by 2 factorial f double dash pi by 4. F double dash pi by 4 is 4. So substitute that value is 4. Then x minus pi by 4 cube by 3 factorial f triple dash 4. F triple dash 4 is 16. And this 3 factorial means 6. 16 by 6 means 8 by 3, x minus pi by 4 bracket cube. And this is the expansion of tan x in ascending power of x minus pi by 4. This is the expansion of tan x in ascending power of x minus 4. So these are some examples on the Taylor's theorem. These are expansion in the ascending power. So if such a type of example that expand in ascending power, expand the function in ascending power of some bracket, some x minus a type function, then use the Taylor's theorem. So another example, expand this 49 plus 69x plus 42x square plus 11x cube plus x raised to 4 in powers of x plus 2. So by Taylor's theorem, fx or f of a plus h is what? F of a plus h, f dash a plus h square by 2 factorial, f double dash a plus h cube by 3 factorial, f triple dash a, right here, f triple dash a, and so on. Suppose this is equation star. Then we take h as x plus 2 and compare with x minus a. So a is minus 2 now. H is x minus a, but it is x plus 2. Therefore, x minus a and x plus 2 comparison, we have a is minus 2. And then write the given function as fx, x raised to 4 plus 11x cube plus 42x square plus 69x plus 49 as fx. And then value at f of a is, that is f of a means f of minus 2 is what? Substitute x as minus 2. So we have the answer 7. Okay. Then f dash x is the derivative of this quantity, 4x cube, then 11 into 3, 33x square, 42 into 2 is 84x plus 69. And then value at a means the f dash a means f dash minus 2 is this, that is substitute x as minus 2. We have answer 1. Then f double dash x, its derivative, 12x square plus 66x plus 84. Then f double dash a means f double dash minus 2, a is minus 2. So substitute x as minus 2. So we have the answer 0. Then f triple dash x is 24x plus 66. Then value at a, f triple dash a is what? 24 into minus 2 plus 66. That is 18. Then fourth order derivative is 24. 24x plus 16. 66, its derivative is 24. Then value at value f raised to 4a, f raised to 4 minus 2 is 24. Then fifth order derivative is 0. So general fifth order derivative we have 0. Then sixth order, seventh order, all the remaining terms are 0. So here write full stop. In the remaining examples, write so on. After this, after finding first order, second order, third order, fourth order derivative, we write so on. That is, the further derivatives are exist, but not equal to 0. The general derivative are not equal to 0. That is, the functions are not. This function is not continuously differentiable. That is, after some order derivative, that is after here we have the after fourth derivative, all the remaining derivatives are 0. So this is not continuously differentiable. Some functions are continuously differentiable. For example, sin x. So its derivative is any order of derivative of sin x is not equal to 0. That is, the first order derivative of sin x is cos x. Then second order is minus sin x. Again minus cos x. Again plus sin x. And in this way, we have infinitely many derivatives. Such a function are called continuously differentiable function. So this is not continuously differentiable function. After some times derivative, that is after either fourth order derivative, fifth order derivative, sixth order derivative, we have the derivative, all the remaining derivative are 0. So this is not continuously differentiable function. So after some, that is here we have the fifth order derivative 0, sixth order derivative 0, seventh order derivative 0. So this function is not continuously differentiable function. So write the Taylor's theorem. That this is the Taylor's theorem. Fx. Right? So write fx means f of a plus h. So fx is this function, the given function x raised to 4 plus 11x cubed plus 69x plus 49 is equal to f of a. F of a is what? Is 7 plus h. H is right x plus 2. F dash a. H f dash a is 1 plus h square by 2 factorial means x plus 2 bracket square by 2 factorial f double dash a is 0 plus h cube, that is x plus 2 bracket cube by 3 factorial f double dash f triple dash a is what? 18. Then next term is what? X h raised to 4 means x plus 2 raised to 4 by 4 factorial f raised to 4 a is 24 and full stop. Then remaining terms are 0 plus so on. No, don't write plus so on, plus dash dash dash. Don't write plus dash dash because the remaining terms are 0. So full stop. And then the expansion, the simplification is what? 7 plus x plus 2, 3. This term is 0. 3 factorial. 3 factorial means 3 factorial 6. 3 into 2 into 1 is 6. 18 by 6. That is 3x plus 2 cube. And this 24, 4 factorial means 24, and 24 by 24 becomes 1. So x plus 2 raised to 4. So this is the expansion of this function in ascending power of x plus 2. If we simplify the RHS, that is if we find this x plus 2 bracket cube, x plus 2 bracket raised to 4, and if you simplify all the RHS, then we have the answer, this answer, LHS, as a LHS. So this is the expansion of this function in ascending power of x plus 2. So already these examples are on Maclaurin's theorem. Apply Taylor's theorem to prove this. Log sin x plus h as log sin x plus h cot x minus h square by 2 factorial cos x square x h cube by 3 h cube by 3 cot x and into cos x square x and so on. And the second example. So by Taylor's theorem, apply Taylor's theorem, pure Taylor's theorem, that is f of x plus h is fx plus h, f dash x plus h square by 2 factorial f double dash x, h cube by 3 factorial f triple dash x. And write f of x plus h as log sin x plus h as f of x plus h. And then fx is what? Substitute h as 0. So in order to find fx, substitute h is 0. So fx is log sin x. So this term fx is log sin x. Then find f dash x. F dash x is log sin x, derivative is 1 by sin x into cos x, that is cot x. Then f double dash x, in order to find f double dash x, the derivative of cos x is minus cos x square x. F triple dash x is what? minus 2 times cosec x into derivative of cosec x is what? Minus cosec x into cot x. That is 2 cosec square x cot x, and so on. And substitute these values in the Taylor's theorem. So f of x plus h as log sine x plus h. The value of f of x plus h log sine x plus h. Then value of fx as log sine x. Then h f dash x. H f dash x is what? H cot x. F dash x is cot x plus h square by 2 factorial. 2 factorial is 2. F double dash x is what? F double dash x is minus cosec square x. So this becomes h minus h square by 2 cosec square x. Next term is plus h cube by 3 factorial. 3 factorial is 6. And the value of f dash x is this. 2 cosec square x into cot x, and 2 by 6 become divided by 3 cosec square x into cot x. That is, we have this, the proof of this first. Similarly, we have to find the expansion of sine inverse x plus h in this form. Apply Taylor's theorem and use f of x plus, denote f of x plus h as sine inverse x plus h. So write first Taylor's theorem, f of x plus h as sine inverse x plus h. Take h as 0, then fx is sine inverse x. Then find its derivative, 1 by, sine inverse x derivative 1 by root 1 minus x square, 1 minus x raised to minus half. Then derivative f double dash x is minus half, its derivative minus half, x minus x square. This is x right here, x square raised to minus half, minus 1 becomes 3 by 2, minus 3 by 2 right here, minus 3 by 2, minus half and minus 1 minus 3 by 2 into derivative my 1 minus x square is minus 2x. So it's become 2 to get cancelled, x by 1 minus x square raised to 3 by 2 and so on. So substitute these values in this Taylor's theorem. F of x plus h as this sine inverse x plus h. Then fx as sine inverse x, plus h f dash x. H f dash x is this 1 by root 1 minus x square. Plus next term is h square by 2 factorial f double dash x. So this term h square, right? H square by 2 factorial. This term h square by 2 factorial f double dash x. F double dash x is this term. And so we have this, and we have to prove this. This is the okay. Sine inverse x is sine inverse x plus h plus this is h square by 2 factorial x by 1 minus x square raised to 3 by 2. 1 minus x square raised to 3 by 2. So these are some problems for homework. Apply Taylor's theorem to prove e raised to x plus h. That is, take f of x plus h as e raised to x plus h. These type of examples. These examples are, right, f of x plus h as e raised to x plus h, and write Taylor's theorem and solve this example. So all these examples are on Taylor's theorem. Expand e raised to x in the ascending power of x minus 1. Again Taylor's theorem, and take x plus h as x minus 1 and a is 1. So similar problem like this. Expand log sec x tan x. So these 16 number problems are, these two problems are on Maclaurin's theorem. Expand sec x. So these are problems for homework. These are also the problems on the Maclaurin's theorem, e raised to sin x, e raised to x into cos x. So all these examples by using Maclaurin's theorem. This is again log 1 plus sin x, fx as log 1 plus sin x, and then write Maclaurin's theorem and write the expansion, find the expansion. So assume the validity log 1 plus x. That is, these are the problems on the again Maclaurin's theorem. Right, fx as log tan x by x, and then find the expansion. Or this is log tan x by x means log tan x minus log x. Expand this by using. So these are the answers of the problem. So solve all these problems in the exercise assignment notebook. Solve all these problems in assignment notebook. So the next topic is now nth order derivative. So we will see the next topic as nth order derivative of some standard function in the next lecture.